But other than that, does anyone have, I was thinking about trying one of the 2 pointers problems. I don't know if people have seen that type of challenge before. We've done a couple with arrays in the past, but I was thinking about starting with the valid palindrome, which is a 2-pointer problem. I'll take silence as a yes. Okay, cool. Oh, cool. Oh, I was actually have in my backlog to record a video on Run.js. That's cool that you found that. Sweet. Mm-hmm. Yep. Mm-hmm. Yep. Awesome. Stratix, welcome as well. How's it going? So, and then Zane joined. What's up, Zane? So, a palindrome is something that spelled frontwards and backwards is the same. So their definition here, a phrase is a palindrome if after converting all uppercase letters into lowercase letters, or vice versa, I think everything to uppercase either way, and removing non-alphanumeric characters. So if there were special characters and or spaces or commas, things like that, it reads the same forwards and backwards. So in this case, we want to define a function, and this is a pretty common problem, so this is a good one for people to see. Define a function that will return true or false if the input parameter s is a palindrome. And so they give a couple of examples. This case, they have the phrase, a man, a plan, a canal, Panama. And you can see the explanation here. So they strip out all of the spaces, all of the special characters, which in this case are commas and semicolons. I think it would be a good exercise to, or if you were doing this in front of an interview, one of the things that I would talk about early on is how do we define what a special character is versus a not special character and how to determine that. And I'll kind of pause really quickly to see if anyone has any thoughts on how do we determine for each individual character, is it a alphanumeric character or is it a non-alphanumeric character? Any suggestions or thoughts on how we check that? Regex. So regex is, yep, we could absolutely use that. Have people used regex before? Are people familiar with what regex is? Yep. That's how it is for me too. And yeah, go ahead, Zane. Yeah, so you could check. Yep, so you can check to see if it's a number. Do you have a way to check if it's a valid letter? Yep. Yep. And Yeah, the ASCII approach is what I was gonna do. And again, as we say words like ASCII and regex, if it's things that you're not familiar with, just let us know and we'll dive into those individual pieces. So this is what I was thinking, the car at method of a string. And what it returns to you is car. Okay, so what does... Okay, so the car code at gives you the ASCII code. And as you can see, like, these are functions I don't have memorized. The way I would talk about these things in an interview, if I was live coding for an interview, is I know there is a function that will take a character and of a string, and it will tell me what the ASCII code is, which in this case, I think is what we're looking for. Yep. And yep. And so if they allow you to Google things, I would go on Google to find the right function. If they don't allow you to Google, the way I would handle that in an interview is to say, like, there's a function that does this thing. I can't remember exactly what it's called. I'm going to call it this in my code that I write, assuming we're not actually running the code, and just go based on that assumption, but explain how my interpretation of that method works, because the expectation is never that you have all the methods and functions memorized. It's that you understand what's out there and you can Google the syntax to finish or to find exactly what you need. But I think more importantly, they want to know you know how to think about breaking down the problem and what pieces you'll need to be able to do that. So I would be looking at this one. So cool. And this is based on you have a string, and then you call the car code at function and you pass it an index, and the character code 1, 2, 3. Yeah. So in this case, they're using both car code at and car at a specific index to get the code representation of that letter and then the actual letter. And they're saying in this case that the lowercase q is equal to 113. And I wonder inside of here, do they give us the ranges for letters? Let's see. They do not. So that's another thing I would be looking at, and I would probably search like JavaScript car code range. Yeah, something in that realm. And Zane started to touch on this. So there's a separate lowercase and uppercase letters are all lowercase letters are together. So it's like 65 to 93 or something. And then uppercase is like, okay, yep, to something. And then uppercase or lowercase is after that. And then the numbers are in there as well. So I'm just looking to find what those specific ranges are so that we can reference them. Cool. Yep. Okay, sweet. So the code that you're referencing is the ASCII code over here. So lowercase letters, yep. Lowercase a is 97. Lowercase z is 122. So we'd have to go from, we would check to see if it is a letter. We would check to see if its code is greater than or equal to 97 and less than or equal to 122. The other thing we need to check for is if it is a number, which is denoted over here. And this would be an ASCII code greater than or equal to 48 and less than or equal to 57. And so if we're able to check all of those appropriately, what we're able to do is ignore all of these other characters that we don't care about. Cool. I don't think, let's go back to the actual tab that we're supposed to be on. Cool. So I have an example of this. It has the explanation, but the output is just returning true or false. And same thing here. Oh, race a car is not, but race car is, so that's true. And then it says empty string, so nothing to do. It does read the same forwards and backwards. Cool. So let's kind of talk about, let's talk about the first step. So the first step is we want to strip out all of the characters that we don't want. So there's a lot of different ways that we can do this. One of the things that I do pretty consistently is something called the accumulator pattern. And it's where we kind of start with a variable. And this would be like, I don't know how we would phrase this, the converted string or the stripped down string or something like that. But we'll call this converted string, and we'll just set this to an empty string. And then we can iterate through the parameters s like it is an array. So we can say I equals 0, I less than s dot length, and then I plus plus. And each individual character we can access by that index like it was an array, because actually string is just an array of characters. So we can get each individual character like this. So s at the index of I. For some reason, this is being really slow, by the way. And then what we want to check is, let's call this current. And we want to check to see if the car code for that is in a given range. So we could create, I don't know if it's my browser or if it's something else. It's being really slow. How? Yeah, maybe, yeah, someone else let me know. Okay. Okay, Zane can see it. Okay. Yep. No worries. But mine is being really slow for some reason. But anyway, so we'll get that current letter, and actually I'll probably change that line of code in a second. But what we also want to do is get the current car code. And so we'll actually get this from s.car code at, and then we'll get it at the index of I. So we can, I guess we could keep that current letter that we defined above. And then what we're going to do is if the car code is in the range that we want it to be, we'll add it to the converted string. So we're only going to add to that converted string. Yeah. Yep. Very good point. So on the, we could do this on the individual letter, or we could do the whole thing beforehand. I don't know if there's definitely not any like significant performance issues there. But we could start with, this editor is being super slow for me. Upper case or lowercase, it actually doesn't matter which one of these you do. I may have to move to VS Code. That's being like, I'm actually going to do this for now because Leetcode is being extremely slow and I don't know why. So give me 1 second. And Quokka is my favorite extension inside of VS Code. It actually does kind of what Liz was saying earlier about being able to run stuff live. So I'm going to type over here for a few minutes, then we'll just kind of copy it back into Leetcode in a second. But let's get an uppercase version, or this could be lowercase. It really doesn't matter. Either one of these is fine. So we could call this lowercase string, and we'll say this is going to be s dot, and I always forget if it's 2 lowercase. Someone to confirm, 2 lowercase. Is that right? Cool. Thank you. Sweet. Can't see your code. Stratix. Can everyone else see my code? I wonder if there's issues going on. Okay. Fun. Okay, so I did application instead of screen. So this now should show VS Code. And I think I have a typo in here of 2 lowercase. So that looks good. Cool. So we'll have our lowercase string. We'll then use that inside of these references. And now we're going to get the character code at a specific index as we iterate through the lowercase string. And then we want to check the current car code. We want to check that it's in these ranges that we talked about. So if we go back to the browser, there's 2 different ranges we want to check. We want to check to see if it is greater than or equal to 48 and less than or equal to 57. So that's one of them. So let's go ahead and do that first. So if this is greater than equal to 48 and current car code is less than equal to 57. So that's one condition. So if it is this condition, we'll wrap that in parentheses. Alternatively, it can be something very similar. So I'm actually going to just duplicate this and then we'll update those numbers. So we will put this condition again inside of here. And then let's go ahead and add our curly brackets. So we have our first condition. We want to say if it is greater than a certain index and less than this other index, 57, or, and that should be 2 pipes, or the current car code is greater than, in this case, if we go back, we're looking at greater than equal to 97, and then less than equal to 122. So 97 and 122 should look like that. If that condition is met, what we want to do is add that on to the converted string. So we'll take the current and add that on to our converted string. And pause really quickly to make sure that makes sense so far. Cool. All right. So if we're in a browser where we can actually test this, at this point, I would call is Palindrome. And then we can take one of their inputs, like this one, and we'll just test to see if it's able to convert this appropriately. So I'll call this with this string. And then at the end of this, I can just log out the converted string. And this Quokka extension in VS Code gives me like this real-time run feedback, which is really nice. Similar again to what Liz was mentioning with run.js. So inside of here, this looks like what we were expecting. So if we go back to what they showed, I think this is exactly what they showed in their explanation and the conversion. So I think that's working correctly. So from here, what we want now is to iterate through the converted string and compare. This is maybe jumping a little bit ahead, like start and end letters. That makes sense. So we're looking at, there's actually a couple things we could do. I'm going this route because it said a double pointer. But one thing we could do is we could have, we have our string. We could get a reversed copy of that string, and then we could iterate through both. So iterate through converted string, compare start and end letters at the same time. 2 would be create a reversed copy of the array, and then iterate through original and reversed at the same time to compare. Usually start in the middle and compare outwards. You could do that as well. So maybe one of the easier, I think the like multiple pointers idea is a little tricky. So we can start with the idea of creating the reversed copy of the string, not array. And the first question is, how do you actually get a reversed copy of a string? Anybody know how to do that right offhand? Mm-hmm. Yeah, so arrays have a built-in reverse function. Strings don't have that, so you have to convert this string to an array. Yep. So how? Yep. Mm-hmm. So to convert a string to an array, we can take the converted string. Say it again. Yep. 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 Which, um, yeah, so a couple things. Strings are not mutable. Yeah. So, important distinction. Strings are not mutable. So you can't like change an existing string. You end up like reassigning the string to a new version of the string. So like this up here is a shorthand. Oops, not that. This is a shorthand for this, right? So what we're doing is assigning this string variable to a brand new variable that uses the previous value. We're not actually directly changing what is in the string to start. Arrays, on the other hand, have a combination of methods that do mutate the original array and don't mutate. Mm-hmm. Yep. 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 So with this part here, what this does is it converts it to an array. And by passing the empty parameter, that's the delimiter in the string. So this is just saying every character becomes a new item in the array. If you pass something like this, it would say every segment. It would take every segment in between pipes as items in the array. So if you had like A, B, C, D, this would then become an array of A, B, C, D. So when we use the empty string, it's just going to take every character and put it into the array. So what that looks like is after calling split, we now have an array of these characters. Now, because it is an array, we can then call the reverse function. So we can call reverse, and now we've got a reversed array. And now we want to convert that back to a string. And so we can then take that array and now call join with, again, an empty parameter. So it takes all of the items inside of the array and joins it all together into a string. And so at the end of this would be the reversed string. So a little tricky. This is actually a fairly common trick that people use, but it's several steps. So again, you take your original string, you call split on that, which converts it to an array. Because you then have an array, you then get the ability to call reverse on it. And then with that, you then need to convert that back to a string, which is what we're looking to work with. Technically, we won't actually need to join that back into a string, but it doesn't really matter either way. So at this point, we would have the converted string, the forward string, and then the reverse string. And what we could do is a for loop to iterate through this. So start I 0, I less than either the converted string or the reverse string dot length. They should be the same. And then I plus plus. And then what do we want to do inside of this? What sort of comparison are we going to make as we iterate through the original converted string and the reversed string? Okay. Yep. So you can do, what was the last part? Yep. So you can do with strings because they are not objects. You can do direct comparisons. If it was an array, we couldn't do that because that would be a comparison of spaces in memory, for example. But with strings, since they're simple types, we can compare them directly. So instinct, and this is kind of my instinct a lot, and you kind of simplify this. So we'll start and then show how to parse this down to what Liz you kind of have there in the chat. We can compare each individual character. So we can take our if condition and we can say if the converted string at I, and then we could check to see if it equals the next thing, but actually we could do the counter of that to see if it doesn't equal the reversed string at the same index. If that is ever true, if those two things ever are not true, we could return false. So we could kind of short circuit through this for loop. Again, we'll shorten this down in a second. And then if we make it through the whole comparison and we never returned false. Yeah, Liz, if you could, when you share code, like solution samples like that, if you could black that out like Mac has, that would be helpful. Have the first part. Yeah. Yep. Yeah, Mac, what's the... Oh, but you can do that with snippets in Discord hide text. Spoiler tags. Oh, you can't do it for multiple lines? Can you not? Yeah. Yep. Perfect. Cool. Yep. Perfect. That's right. Yep. So if we make it through this whole comparison and we never return false at the end, we can assume that we'll return true. But to everyone's point, we have now created two strings that people can compare directly. And a lot of times what we see people do is do something like this. If converted string equals reversed string, return true, else return false. So we see that happen a lot. But yeah, so the Boolean, yeah. So this comparison already is returning the value that we want. So what we could do is to get rid of all of this and just return that comparison. So we could return the comparison of converted string equals the reverse string. In this case, absolutely. Yeah. Yep. Yep. There's also, we don't necessarily have to convert this to a variable. So we could move the comparison directly up like this. So I like to set things like this to variables. I just feel like it reads better and we can be more explicit with variable names. But we could do this comparison right in line. Now there is another interesting way that I think would be good for practice. Let's go back to getting the reverse string. Actually, let's do this without the reverse string. So that is, let me actually go back to, nope. Sorry, 1 second. So return converted string, that. So this is one solution, and this would be creating a reverse copy. This is a pretty common solution. And again, this is a useful snippet that I think is you're very likely to come across and use. But the other thing that we can do, or actually let's do it this way. What's the downside from a performance perspective and from a memory perspective? This is getting a little technical, but there are details that are important to understand here. Mac, you got like half of it. So what could be the downside of this code, and specifically looking at the effort that we're having to do over here? Yeah, absolutely. Yep. So we are creating, and at some point, the actual, like, we're creating another string at the end of this. So we're creating another string that we're then comparing. In the middle, I actually don't know the answer to this. Like up until this point, this is also creating an additional array in memory. Even though we don't assign it to anything, it's still in memory at some point. And then this augments that array. So that array is still there. And then we create this new string. So by running this code, we're creating an additional array in memory and an additional string. So this is very nitpicky, but I think it's like fun to understand the implications. Is we're creating unnecessary copies of data that we don't necessarily have to. What about, so that's space complexity. What about time complexity for this? Mm-hmm. Yeah. How would you quantify the time complexity of the highlighted code there using those array and string functions? Yeah. Should I say that again? Yep. And I think, Karina, I think that's what you were saying as well. Is that right? Yep. Yep. So this would be O of 3n just for like starting point, and then constants go away because they're negligible. So each time we call one of these functions, it's O of n that it takes. So we do that 3 times, which becomes O of 3n. That then becomes O of n. So we've talked about the time complexity and the space complexity of this option. If we do the multiple pointer thing, and this is actually the category that they have this in. I don't know if do they list it on this page? Anyway, they talk about the double pointer. And so the double pointer solution to things is to start a pointer at the start of something and the end of something, increment the start one, decrement the end one, and then eventually they swap over and you do comparisons along the way. So that's what we can do here. And by doing that, we are not creating any additional information or objects or variables in memory. We are only using the one that we're given. And then technically the big O notation is O of n divided by 2, which that divided by 2 is also negligible. So the time complexity would be the same, but we would save on space of what's created. So we could, I guess we could start with an end variable, and we could set this to the length of the array because we want the end variable to be the last index. And so we could set this to the converted string.length. And we actually need to change that just slightly. Does anyone know what change we need to make to get the last index? Yep, because zero-based indexing. Mm-hmm. Yep. So what we'll do is we'll have our end and our start. We'll increment and decrement them. And our breakout condition will be when the end is less than the beginning. So we can write a for loop for that. Typically, for loops are always I, like just by default, but I'll actually call this begin, and we'll set that at 0. We'll say while begin is less than the end, and then we'll begin plus plus. So we'll increment the begin. And inside of here, we'll have the same condition that we had before. So if the converted string at index begin does not equal the converted string at end, we will return false. So we'll just short circuit. If any of those comparisons are not equal, we'll just short circuit out of there. Otherwise, we will additionally decrement end. And I think that should do it, but I'll take a second to review and also everybody else look as well. Mark Canark? Or no, sorry. Is that an old name or am I just making it up? Lava Coder. Did you also use Canark? Okay, cool. Just making sure I'm not. Yes, great point. Yeah, I missed the return at the end. So if I get to the end of this, we assume we went through and compared everything and it was true. Cool. Hello, baby. It's a little, yeah, so it's a little, yep. So it's a little different. It's additionally, I think, in my mind, like much more complex, although the idea of breaking down the comparisons is valid. But with those sorts of algorithms, you're dividing and conquering where you take half, you divide everything in half each time to the point where you get down eventually to individual things that you can compare. And I think that time complexity is n log n, I think is how that works. Cool. So I think practicing both of these approaches is good, especially this one. Like if you walk into an interview and you just do this part that's totally fine. And I think doing that with confidence is great. You may be in a situation where they ask you to do it a different way to see if you're able to kind of implement the double pointer algorithm. So I would definitely practice this or use this a few times if you're preparing for those types of interviews. Yeah. And then I will, while you're doing that, we should actually copy this into here and see if it actually works. Jesse, you just hanging out. My wife and baby came in, sitting on the couch in the office. Just are you sending it in chat? Oh, a DM. Okay. Do you want me to can I bring it up on the screen that I'm sharing? Okay, cool. Let's do that. Cool. So you keep your, let me zoom in for people. Mm-hmm. Yep. Yeah, so you have standard for loop. You then start an index each time. Then if the right symbol is not equal to, then you break. Also, actually, so this won't have a significant impact on O of n or on your big O notation, but technically this will be O of n instead of O of n divided by 2, because you don't have the ability to break out of the function after those pointers have swapped over. So yours is actually having right and left. And so they go to this point and then they swap, and you're still comparing all the way across, which means you're going to be comparing those things twice. It's negligible in terms of performance, but there is a slight performance implication in this one versus checking to see when they swap over and then calling that done a little early. Not after is equal is false. So let's assume that everything is equal and you have left pointer, right pointer, and you're incrementing and decrementing each time, and then they swap over. So at this point, when they continue to go until the end, they are now comparing the same things that they've already compared, if that makes sense. Do you want to we could do a, do you want to like write that out as an example? Okay. So let's say we have a string A, B, C, BA, for example, right? We have left pointer and right pointer. Okay. So this is comparing A and A. Great. That's true. We may need to make this will still work. So we say that's true. So now we continue to increment. So we move L this way and R that way. So now we compare B and B. B and B are both equal. Then we do this where they're on the same index. Oops, not that. Right? So L is still moving to the right. R is still moving to the left. Okay, so they are equal here, which is good. We then move L to the right. We move R to the left. And so now they flipped sides. So now we're comparing right and left still. But this comparison of this B and this B has already been done. Same with the comparison of this A and this A. So you're doing each comparison, except for maybe the middle one, twice when you only need to do that comparison once. Cool. Yes. Yep. you they may not. That actually depends on the length of the array, whether or not it's even or odd. Mm-hmm. Yep. So they would go from like, I don't know how to come up with a demo, but exactly what you said. It depends on if it's even or odd. And Karina, yes, you could update the if condition here to be, or the I condition, the for loop condition for I, to be able to check to see if you go beyond the center point. Calculating the center point always confuses me. Like it's not that big a deal, but you do have to do, like if you have five elements and you divide by 2, you get 2.5, and to max point you need to floor that to get to 2. And that, yeah. That'll, see, that's what, is that true? So AB's indexes swap. Mm-hmm. Yep. Exactly. Yep. Yep. So in this case, and this is why, so I'm 100% with what you said, because the calculated midpoint, I feel like always confuses me for no particular reason. Yeah. Yeah. True. Yep. Yep. That's a good point. So then that's extra logic, I think, to factor in of how to calculate that, because if it's odd, we do one thing versus if it's even, we do another. Yeah, no. DCBA. Oh, wait. Wait, but that's odd, right? Yeah, I think for even you have to do this. Oh, but actually that's answer, but then this also divides cleanly. To a say what? The half point. So if we take a length of 8, we divide that by 2, we get 4. And then if we're doing zero-based indexing, that actually goes like 0, 1, 2, 3, 4, which is the 5th one. So that would actually be like a -1 type thing. See, this is why it annoys me to calculate midpoints, because I feel like it's trickier than it should be. Mm-hmm. Anyway, so yeah. Anyway, I'm definitely always floor. Yeah. So I'm definitely a fan of like the begin and end, and have the condition built into the for loop for checking if begin becomes less than end. Is that right? Begin. No, this is also wrong. Begin greater than end. No one caught that. Right? Because begin is going to start less than, thank you, Jess. Begin is going to start less than end. And then as it swaps, it's going to be greater than. That's going to be our cue. It was fine the way it was. which should, so to start, begin will be 0 and end will be the length of the array minus 1, so 6 or something. So it will be less to start. Oh, sorry. Okay. I was thinking of breakout condition. My wife has my daughter on the table trying to distract me, and she's doing a very good job. Are you going to give her to me?
Oh, I didn't see your hands.
Oh. My wife is obviously very bored. Not so shy. Can you stand up there? Look at the camera. So many bright lights. Okay. What we haven't done in all of this is actually run this code. You don't trust me to hold her with one hand while I run code? Yeah. All right, let's run this and see. Accepted. Cool. So we got that. Really curious to see what the, so this should be, so we beat 77% of users, which is really interesting. I always wonder like what additional things people do to be able to optimize even more. Yeah, go for it. I actually have no idea how I have no idea what the performance implications of regex are, to be quite honest. So that is one thing. I also feel like regex is very, very tricky. I don't know regex syntax I can never write any regex from scratch, and I've never tried to be able to do that. So I personally wouldn't. I might mention that in an interview to just cover the fact that I know what it is and say, I would go and Google a regex syntax to be able to do this. I think that would be a good thing to do, just to reference that you're familiar with the idea. There's just not that many people, I think, that actually write that from scratch. I think it also, like if you're in an interview, I think that would be very intimidating to yourself to be trying to come up with that on the fly. So my personal opinion would be to not use regex, but I would address that as an option that we could use. Mm-hmm. Cool. Yeah. Mm-hmm. Okay. Mm-hmm. Yep. Yep. Just personal choice. Absolutely. Whichever of those, if you're super comfortable with that, with regex, absolutely do that. This is what I expected with regex performance being O of N, because it's basically doing behind the scenes and iteration and comparison similar to what we're doing. So I think the time complexity of this would be the same because it's iterating through each letter in the string. But yeah, if you're good with that, I think people would be very impressed, to be honest, if you did that. I would also, just from a practice standpoint, kind of get used to working with car codes and the car code at function. I think those are useful and can show up in different types of questions as well. But for this particular one, if that's the solution that makes the most sense for you, I would absolutely do that. Mm-hmm. Yes. Yeah. And we maybe, so let's actually see how they phrase this. Cause they did actually call it pointers. So pointers in different languages, other than JavaScript, have actually, I guess they have significance in JavaScript as well, have implications on how objects are passed by reference and value in pointers. And you can actually specifically use pointers in things like C. So it has a deeper implication, but in this case, this is a higher level interpretation of pointer, just to say you have two references to something inside of, in this case, a string. So you have the beginner and the end pointer. Mm-hmm. Right. Yep. Mm-hmm. Yeah. So recursion gets expensive because of space, because you're creating, depending on what you're passing, if it's by value or reference, but then the function itself, I believe, has space complexity. And so if it's a really long recursive solution, I think it could have significant implications in terms of space complexity. I'm not that well versed in recursion. The short answer, though, to backtrack a little bit, is whatever solution you have that comes to mind, do that first. You may be in a scenario where you solve this quickly, and then they say, okay, could you do a recursive solution to this as well? So they may ask you to go either way. If you do recursive first, they may ask you to go the other way. But the most important objective is for you to be able to show that you're able to solve the problem first and foremost. So whatever comes to mind, whatever solution is, do that first and get that right. And then you can have conversations of, do I need to show you another way to do things? Are you satisfied with what it is? There's also, you certainly would want to keep in mind big O notation as you're solving this. But a lot of times, in my mind, it's better if you can't come up with a more optimal solution to do like a brute force solution to start, which is typically going to be O of n squared. To be able to do that first, get a solution, and then talk through what's there to see how to optimize that with your interviewer. All of that to say, like, whatever solution you come up with first to be able to solve the problem, absolutely do that. And then you can iterate on that if they ask you to, and or ask you to do a separate solution or a different approach to the solution. Every function does. Yep. Yeah, for me, yeah. Yeah, the time complexity should be the same because every function is just doing that exact same thing that we would do, which is actually a really interesting exercise that I recommend a lot of people do, is just write these array functions from scratch to understand how they work. I think the time complexity would be the same. For me, a lot of times I find myself trying to use those array functions, and the readability, once it gets to like slightly more complicated, is I just prefer traditional for loops a lot of the time. So readability becomes a concern for me sometimes. There's also the obvious comparison that we talked about earlier, where we could compare those strings directly instead of going through. Also, yeah. They are fun. Yeah, yeah, yeah. Yep.